Now we're going to talk about flow rates and dosage rates for IV. Flow rates are measured in volume over time, such as milliliters per hour or drops per minute. Dosage rates are measured in drug over time, so we could have something like milligrams per hour or milligrams per minute. When we're talking about our flow rates and our dosage rates, we need to worry about the time, the volume in milliliters or the drug in milligrams, and the flow rate in milliliters per hour or the dosage rate in milligrams per minute. That's what's going to the patient. So when we look at an order, cimetidine 300 milligrams IV PB, so intravenous piggyback, every 6 hours, in 50 milliliters normal saline, infuse over 20 minutes. We have the drug, the cimetidine, the amount of the drug, 300 milligrams, what it's diluted in, the 50 milliliters of normal saline, the duration, that it's 20 minutes, and how often it's repeated, every 6 hours. Here, they ask us to find the IV flow rate measured in milliliters per minute. So if I look at what's going on, the milliliters is this 50 milliliters. And they're telling me how long the infusion takes, 20 minutes. They did ask for milliliters per minute, so all I have to do is divide. That gives me 2.5 milliliters per minute. Now, normally we round flow rates to the nearest whole number. That 5 tells me to round up. So if I was rounding to the nearest whole number, I'd say 3 milliliters per minute. They also asked us to find the dosage rate measured in milligrams per minute. So if I look, they tell me that it's 300 milligrams of this drug over that same 20 minutes. If we do that division, we find that the patient's getting 15 milligrams per minute. If we look at another example, our order is cefoxitin, 1 gram, intravenous piggyback, every 6 hours, over 30 minutes. First, we're going to find the dosage rate in grams per hour. If I look at the problem, they tell me that this patient is getting 1 gram every 30 minutes. So I have the numerator correct grams, but I need to convert those minutes to hours. I know in 60 minutes, there's 1 hour. So I'm going to multiply straight across. That gives me 60 over 30. When I divide, that tells me that we have 2 grams per hour. If I look at the next question, it says find the dosage rate in milligrams per minute. So in the same situation, we're looking for milligrams per minute. So I'm going to start out 1 gram over 30 minutes. This time, instead of changing the time, I need to change that gram. So I know in 1 gram, there are 1,000 milligrams. When I multiply straight across, that gives me 1,000 over 30. When I divide, that gives me 33.3 repeating milligrams per minute. I'm going to round this to the nearest whole. That tells me that there's 33 milligrams per minute. If we look at another example, it says the medication order reads heparin, 1,250 units per hour IV. See the label and calculate the infusion rate in milliliters per hour. So we start out with that rate they gave us, the 1,250 units per hour. I want to get to milliliters per hour. So that's telling me I need to look for something that relates units to milliliters. They are up here in this red box. So what I typically do is pick the one that has the smaller number value. So I'm going to use the 50 units per milliliter. I'll put the 50 units in the denominator, so units will cancel out, and the 1 milliliter up in the numerator. When I do that, that gives me 1,250 over 50, and when I divide, it gives me 25 milliliters per hour. Now we only need to do this once, but I'm going to do this using the other rate that they give us on this label just to prove that it doesn't matter. So I could have used that same information from the problem, the 1,250 units per 1 hour, but instead chose to use that top rate, that there's 25,000 units in 500 milliliters. When I do that, I end up with 625,000 over 25,000. And when I divide, that also gives me the 25 milliliters per hour. If I look at another example, it says an IV bag contains 1,000 milliliters of normal saline with 500 milligrams of a drug. It is infusing at 12 drops per minute. The drop factor is 10 drops per milliliter. If the recommended dose is 0.5 to 2.5 milligrams per minute, is this infusion in the safe dose range? So if I look at what's safe, the units there are milligrams per minute. So I'm going to get the order in terms of milligrams per minute so I can compare it to that safe dose range. So if I look at what they give me, I know that the bag contains 1,000 milliliters in 500 milligrams. Because I want milligrams up in the numerator of my answer, I'm going to start with the 500 milligrams up in the numerator over this 1,000 milliliters. And I'm going to use information from the problem to get rid of the milliliters and get it into time. So they tell me that there's 12 drops per minute, so that has time, but it doesn't have milliliters in it. And the drop factor is 10 drops per milliliter. So I'm going to use this 10 drops per milliliter to cancel out milliliters. I'll put 1 milliliter in my numerator so the milliliters cancel out, and 10 drops in the denominator. Then I'll use this 12 drops per minute to get to time. 12 drops goes in the numerator, so the drops will cancel out, with 1 minute down in the denominator. I wanted milligrams per minute. Those are the units that are left. So I multiply straight across to find that I have 6,000 over 10,000. When I divide out, that gives me 0.6 milligrams per minute. If I think about that safe dose range, it was 0.5 to 2.5 milligrams per minute. So the order 0.6 milligrams is in the middle. It's between 0.5 and 2.5, so that means yes, it is safe. If we look at another order, we have an order for heparin, 40,000 units, continuous IV, in 1,000 milliliters of dextrose 5% water, infused at 30 milliliters per hour. We want to know, is the order in the safe range? If a normal heparinizing range is between 20,000 and 40,000 units per day. So same thing, I'm going to try to get my problem, the order in units per day. So they tell us that we start with 40,000 units, and it's continuous IV in 1,000 milliliters. So I have 40,000 units in 1,000 milliliters. I want to get rid of milliliters and get to days. So they tell me that we have 30 milliliters per hour in the problem. So I have 30 milliliters in 1 hour. So now I have units per hour. I want units per day. I know there's 24 hours in 1 day. The hours cancel out. I'm just left with days. So when I multiply straight across, I get a large number in my numerator over 1,000. I'm going to divide, and I'll find that we have 28,800 units per day is the order. If we look at that safe range again, it was between 20,000 and 40,000 units per day. Our 28,800 is in that range. It's in between 20,000 and 40,000 units per day. So we say yes, it is safe. If we look at one last example, it says a patient is receiving an infusion of 0.5 milligrams per minute. The concentration in the intravenous piggyback bag is 100 milligrams in 200 milliliters. The first question is how long? So we're looking for time. Will it take the patient to receive 40 milligrams? So if I start with that 40 milligrams, I want to cancel out my milligrams and get to time. Well, they tell us in the problem that it's 0.5 milligrams per 1 minute. So if we multiply straight across, we have 40 over 0.5. Our units are just minutes, so we have 80 minutes. Or if we want to write that as an hour and minutes, we can say it's 1 hour, 20 minutes, depending on how they asked for the answer. If we look at the second question, they ask us how many milliliters will the patient receive in 30 minutes. So I'm going to start with that time, that 30 minutes. I want to get rid of time and get to volume. So the only thing I have from this problem with time is still that 0.5 milligrams per minute. So I'll have in 1 minute, the patient's going to get 0.5 milligrams. But I don't care about milligrams, I care about milliliters. So they tell me here that there's 100 milligrams in 200 milliliters. I make sure that my milligrams cancel out and I end up with milliliters. When I multiply straight across, I end up with 3,000 over 100 or 30 milliliters.